Okay, so here we go. We are up to 2-6, day 1. Kind of a sweeping overview of a lot of the ways we've learned to solve trinomials or quadratics. Easiest way possible is factoring. As you notice, you got a 1 here. You're like, okay, sweet, I'm going to try to factor. So, these are x's. Oh, that's not supposed to be negative 16. It's supposed to be negative 6. All right. So, what are the two factors? Negative 8 and 2. What are my possible solutions? 8 or negative 2. All right. So, some of you may ask, well, why didn't you just show us this easy one? Why do we even need to do this? I'm going to answer that. I'm also going to try to explain the benefits, the pros and cons of each possible technique. So here we go. Completing the square. Definitely a little bit more complex than factoring. In order to complete the square, this must be a 1. Remember that golden rule. And then what we're going to do is we're going to kick that constant over, create some spaces. So if I add 16 to both sides, I'm going to get 16 plus space. Got to take half of that. Half of that's negative 3. Then I got to square it. A 9 and a 9. Get rid of this. So what is this? If I've done it right, it's a perfect square trinomial. X minus 3 squared equals 25. Bada boom, bada bang, do the right thing. Very important you do the right thing because that's where the two answers are going to come from. So x minus 3 equals plus or minus 5. Now this means x minus 3 equals 5. It means x minus 3 equals negative 5. Add 3 to both sides, I get 8. Add 3 to both sides here, I get negative 2. Notice, same answers, different technique. All right, what's the benefit of completing the square? Honestly, I would never complete the square unless the questions were more kind of pinpointed about parabolas, like where's the vertex? What about the shifts? What about the vertical compression or stretch? That's when you're going to have to complete the square because it puts it in vertex form for you. So it's not useless. And Algebra 2 loves working with parabolas in the transformation world. So keep that in mind. Not a waste of time. And now the quadratic formula. Quadratic formula, this is actually equal to x or y or whatever the variable is, but typically we use x. A in the formula right here and here comes from the coefficient of your squared term. B, which shows up here, coefficient of just your x. C is your constant. So first of all, notice how it's set equal to 0. So if you come across a homework problem and it's equal to some stuff, you're going to have to subtract things, move stuff around, so you set it equal to 0. Then identify what A, B, and C are. Now, with that being said, A would be 1. B would be negative 6. C is negative 16. Just going to plug these into this nice little formula. That basically says take the opposite of whatever B is. Well, if B is negative 6, then I got positive 6. And then negative 6 squared minus 4 times A times C all over 2A, which is 2. Now we got to kind of simplify this mess. So we get 6 plus or minus the square root. Negative 6 squared is 36. Notice minus 4 times 1 times negative 6. These two would make positives because a negative times a positive times a negative is positive. That mess makes us 64. I'm going to shorten this just a smidge. All over 2. Now if we add these together, we get 100. It's kind of like a PEMDAS thing. You got to clean this up first. So this would be 6 plus or minus the square root of 100 over 2. Now we have a little advantage because we know our answer is going to be 8 or negative 2 because that happened with the previous two techniques. We do a little work in our head here. Well, what is the square root of 100? Well, that's 6 plus or minus 10 over 2. 6 plus 10 is 18 over 2. Excuse me, 6 plus 10 is 16. Divided by 2 is 8. 6 minus 10 is negative 4. Divided by 2 is negative 2. So there's where our two answers come from the quadratic formula. You can see all three techniques work. Just depends on how the problem is presented to you as to which one you choose to use. All right, with that being said, I got more to teach you about the quadratic formula. Today is kind of like, hey, let's use the quadratic formula. What does it mean? How do you use it? And then tomorrow we're going to apply some story problems, real life work that involves the quadratic formula. So don't go anywhere. Here's the other part. Okay, so remember, this is the pre-lesson, so I'm trying to just build the foundation for this idea. Make sure to watch the example problems, and then I'll really pull it all together for you. But just in general now, parabolas have three different solutions, three different ways that they can be graphed, essentially. Don't forget, we're talking, when we say solutions, we're talking about the zeros, and this is a massive thing to understand right now. That means that right here, y equals 0. Y equals 0, because those are my x-intercepts. That's what we're trying to solve. There's always a little bit of confusion, and it took me a while to understand this as well. You are not trying to find that. That is your y-intercept, and so that's where x equals 0. Obviously, we're finding x equals -2 and x equals 8. So we're not looking for where x equals 0, so don't look for your y-intercepts when they ask you for your zeros or your solutions of your parabola / quadratic. I know that's a mouthful. Having said that, we're going to use the discriminant. Now the discriminant is a chunk of your quadratic formula. Your quadratic formula is right here. The only part of it we're going to be concerned about is this, because they're going to back off from asking you specifics. What exactly are your zeros? They're going to ask you, hey, does the parabola have 0 solutions, 1 solution, or 2? Clearly, this one has 2. So if we were to graph it, it would look something like this. And this would be my 8, because that'd be 8 comma 0. And this would be my -2, -2 comma 0. But the whole lesson is about the discriminant. We're going to use this piece of information to determine our answers without actually figuring out what our answers are. Maybe that's confusing, but I'm going to try to explain it. When we did this a few seconds ago, we ended up getting 6 plus or minus the square root of 100 all over 2. Now I want you to notice something. We have in our discriminant, that's whatever ends up in here, we ended up with the square root of a real number. Now, a real number could be anything, any positive number, okay? I should have said real and positive. That'll make sense on another example. So we have the square root of 100. Well, what does that spit out? It spits out 10. Where does the two answers come from? The plus or minus. So we have 6 plus or minus some stuff all over 2. They're not asking us what are your answers. They're asking how many answers are you going to have. If you end up getting something like this, you go, aha, there are 2 solutions, 2 zeros. What about this one? This one, and by the way, I'm just rolling out some rules, but we're going to work on it on our sample problems next video. So if you have another equation and you plug it in and you get to the discriminant and the discriminant is 0, in other words, you've got -b plus or minus the square root of b squared minus 4ac, and then all of this stuff somehow ends up equaling 0, doesn't matter what it's over. Notice the square root of 0 is 0. We'd have some number over some number, and that would give us 1 answer. They're not asking us what is the answer. They're asking how many solutions does this parabola have. And you can see a visual image comes down and touches it where the vertex touches the x-axis. Now, notice I already said don't worry about the y. Don't worry about the y-intercept. So what they're asking is, all right, there's a third type where there are no solutions because it doesn't cross the x-axis anywhere. Well, what's this have to do with the discriminant? Well, if you think about it, if we have the square root of any negative number, for example, the square root of a -100, That's an imaginary number. My x-axis, all the way this way and all the way this way, are real numbers. So I'm going to end up with a real number. I need to have a real number in order to have a real solution. This is an imaginary number. It doesn't even exist anywhere on our x-axis. Over here I said real and positive. Just keep in mind this just needs to be any positive result, and then that will spit out 2 zeros. If that was slightly confusing to you, I apologize. Hang in there for your sample problems. I'll make sure it's clear. All right, there's your pre-lesson.